Hello everyone, my name is Jayant and I'm a student doing my final year in MS Ramaya Institute of Technology. In this video, I'm gonna give you a demo about Apache Storm. So before giving a demo, let me give you a brief introduction about Storm.
So, what is Storm? Storm is a distributed computation system which processes streams of data reliably and in real time. So, by distributed, it means that it runs on many nodes or clusters or systems. So, and it does what Hadoop does for batch processing. So now we'll see what are the advantages of using Storm. So first is its guaranteed data processing. So this means that each data point is processed at least once. So next is horizontal scalability. So it means that if we add extra nodes to the cluster, the system doesn't break down and functions normally with the effect of added extra nodes. So next is fault tolerant. So if any node breaks down, the cluster doesn't break down, it instantly recovers from that error. So and there are no intermediate message brokers. So and this the inputs are abstracted so that we can write the code in higher level languages and need not worry about the lower level message passing. So that's what higher level abstraction than message passing means. And the next is it can be used with many programming languages, and it's also free and open source. So now we'll see the use cases of Storm. So first is real-time analytics. Next one is online machine learning, continuous computation, distributed remote procedure calls, extract, transform and load, and many more. So next I'll talk about Storm cluster. So basically there are three types of nodes in a Storm cluster. So first one is the master node or the Nimbus node. So the Nimbus node is similar to a job tracker in Hadoop. So Nimbus node assigns the work to individual worker nodes and manages them. So the zookeeper nodes does the cluster coordination, that is it helps in communication between the Nimbus and the supervisor, that is the master and the slave nodes or worker nodes. And the individual worker nodes executes a subset of the topology, and the supervisor is the daemon which runs on the worker nodes, which waits for its action from the Nimbus. It waits for certain process to be received from the Nimbus. So next is the concepts of Storm. So basically there are mainly four concepts in Storm. So first one is the stream. So stream is nothing but a sequence of tuples, as you can see in this figure. So the stream is how a data flows in the Storm topology. So next one is the spout. The spouts are the generators for the input stream. So you can give the spout to some queuing service or a sensor in output or some streaming API, and it generates the streams for this topology. That is the sequence of tuples for this topology. So next is the bolt. So bolts they process the input streams generated by the spouts. So bolts can do functions such as aggregation, filtering, joining, and etc. So and then the last one is the topology. A topology is nothing but a directed acyclic graph network of spouts and bolts. So a topology is how you submit a computation for the Storm to process. It is similar to a job in Hadoop MapReduce. So this is an example a topology. As you can see, there are two spouts here, two spouts and four bolts. So and one more thing is that the spouts and bolts are parallelized, so they can contain many threads. So this is about the introduction to Storm. So next let's look at how to install the Storm on Ubuntu, and then after installation I'll give a sample With a sample topology, I'll explain how to run it. Now I'll be showing you how to get Storm running on Ubuntu. Storm uses Zookeeper service for its cluster coordination. So we'll first download and configure Zookeeper and then move on to Storm. So before we get started with Zookeeper, first make sure that you have JRE and JDK installed on your system, that is Java Runtime Environment and Java Development Kit. And you have set the Java underscore home environment variable properly pointing to the bin directory of your JDK. So now let's download the Zookeeper service. So this is the Zookeeper archive and you can download it from here. So I already downloaded it, so I won't be downloading it again. I have given a link of this page in the description, and this is the downloaded archive. I'm going to extract it here. So basically you need to do two things here. First is you need to create a directory in which the Zookeeper service can store its data. So I'll create a new directory and name it as data, and you can name it anything as such and there's no specific name. And second, in the conf directory you need to create a new configuration file named as zoo.cfg, and the name of this file must be zoo.cfg and you can give any arbitrary name. So in this file you need to add these lines here. And the value for data dir must be the path of the directory which you created earlier, that is this path. Okay, you can save this. So once we are done with it, we can check from the terminal whether the Zookeeper service is running properly. So to start Zookeeper service, just go to the Zookeeper folder and in the bin folder you will find the zkserver.shell file. Just run it. So now I'll start the Zookeeper server. Start. So as you can see, this is using the configuration file which you provided earlier and it started properly. So now I'm gonna stop it. Yeah, so once we are done with the Zookeeper, now we can go on for we can download and configure Storm directly. So this is the download page for the Storm. I have already downloaded it, so I won't be downloading it again. I have given a link of this page in the video description. So this is the downloaded Storm archive. I'm going to extract it here. So similar to what we did for Zookeeper, we need to do two things here. First is we need to create a directory in which the Storm can store its data. So I'm going to name it data. And in the conf folder, you need to add some lines in the storm.yaml file. And here the path must be the directory path which you have. The value must be the directory path which you created earlier in the for the Storm folder. Okay, once we are done with this, we can start the Storm in terminal and see if it's working properly. So to start Storm, you need to first go to the bin folder I need to start use the storm.py to start it. So I'll just go to the storm folder bin, and now first I'll start the Nimbus service. Sorry, Nimbus node. Oh, sorry. Before you start this, make sure you have the Zookeeper service running. So now we'll start the Zookeeper service, which I had stopped earlier. So it's zkserver.h start. So it started properly. Now I'll start the Nimbus. So now Nimbus is running properly. So to create a supervisors, you need to do it in a separate terminal, and you can't do that in this terminal itself. So I'm opening a new terminal. I'm changing my directory to bin of the storm, and then I'll use the same storm.py file to create supervisors. So now it's trying to run the supervisor, and it succeeded. So in order to check whether everything happened properly, we can use the storm UI option. It is from the py file. So basically this gives a web interface. So once that's running, you can go to your web browser and type localhost colon 8080. So it gives the summary of the storm cluster, like whether everything happened properly. So as you can see, the Nimbus is active, that's leader, and the topology we haven't given anything, and the supervisor created one, it's running properly. So this is how you set up the storm. So next we'll move on to the example part. To submit a storm topology to the storm cluster, we need to first create a jar file from the .java files. So there are two approaches for doing this. So first approach is you manually add all the class paths required by the .java file into the project, and then create a jar file. And the second easier approach is to use the Maven build tool for creating a jar file. So we'll be following the second approach here. So this is the download page for the Maven tool. So download it if you don't have it yet, and I won't be showing you how to configure it. It's easy and it's given here. And for our example topologies here, I will be using the ones in the Storm starter project, which is available along with the Storm tool. These So I'll be showing you the word count topology from this. Okay, the first is to go to the root directory of your project, that is the Storm starter. And then type so it cleans your project and adds all the class paths, that is the dependencies required by your project. So when you run it for the first time, it will take a lot of time. So it downloads all the class path, the libraries, the jar files required by your project, and then builds it. So since I've already done it, so it's not taking much time here. So if you get the build success, then it means the Maven tool built the class file successfully. So after building it, you need to create a jar file. So that can be done by typing mvn space package. So this will create a jar file from the class files. So as I said earlier, even this also will take a lot of time. And so since I've already done it, it's not taking much time here. Okay, when the build succeeded, so after you create a jar file, you select which topology in the available topologies in that project you wish to execute. And for the demo now, I will be taking word count topology. I will show you how to execute it on a local machine, that is without the Nimbus supervisor and the Zookeeper services, and on the cluster, that is with Nimbus Zookeeper and supervisor. So first is I'll do it on a local machine. So first head over to the target folder, which is created by that Maven tool. So it contains that jar jar file which is needed for running the topology. So and I've added the bin folder to the environment variable, so that's easy for accessing. So the syntax is storm space jar space the jar file which is obtained after the Maven tool, or if you're building it manually, and then the topology which you want to execute. So since I haven't started the Zookeeper, the Nimbus and Supervisor services yet, so this is running in local mode. Topology. So this will execute the word count topology. Yeah. So as you can see here, the bolt and the spout tasks are happening. So that means it's working properly. So now I'll stop this process. So now we will see how to execute this topology on the cluster. So first is to start the individual services, that is the zookeeper, nimber and the supervisor. So which will be doing it now. So to start a zookeeper service, you need to go to the bin folder and type sh space start. So now the zookeeper service started. So to start the Nimbus and the supervisor service, you need two separate terminals. I'll start the Nimbus here. So I'm able to do it without changing the directory because I've added that folder into the class path. So similarly, I'll start the supervisor. And also the web UI. So all three have started successfully. Let's just verify it once. Okay, so as you can see, they have started successfully. So let's give the topology to this cluster now. So to give the topology, it's just the same approach. So without these three active, it will do it in local mode. With these services active, it will give it to these nodes, and then they will perform the computation. So I'll first cd to that folder, this tom examples starter target, the location of the jar file. Okay, and then give storm jar, name of the jar file, and then which you want to execute. For this I'll give fast word count topology. Let's check the name once. Yeah, it's fast word count topology, this one. Dot apache dot storm. Yeah, and the naming convention is here. The org.apache.storm.starter is the package name, and fast word count topology is the class name. So as you can see here, it's submitted the topology, and the name of the topology is WC test. So let's verify it once on the web UI. So as you can see in the topology summary, the WC test is here. So you can see how many sports are active, how many bolts, etc. here on the information here. So if you want to kill it, just can type kill and the topology will end. So this is how you give a topology using the Maven tool for the Storm cluster or the local machine to perform computation.